You know, as a species, we like to anthropomorphize, but, you know, I weigh 160 pounds and I'm 5'8". That animal we were with yesterday probably weighed 42 tons and was 45 feet long. I mean, you can't anthropomorphize. It's living in a world of sound. I'm living in a world of sight. You know, we live on planet ocean, not planet Earth. 71% of the planet is ocean. They say we know more about the surface of the moon than our oceans. Well, I think that's great. For God, I mean, great. That means it's a very exciting time to be in oceanography. I also think as humanity fills up our land masses, we will be looking more and more to the oceans for all the different needs that humanity has. And I think that these tools we're developing are democratizing science. Let's be, again, a little proactive. If you're driving the car and the front wheel feels like it's wobbling, you stop the car, you have a look, you tighten up the wheel, you don't speed up. I think it's time for us to understand, again, we live on planet ocean and it's in our own self-interest to have healthy oceans, and whales are key to helping us know what's going on.
Welcome to Commercial Drones FM. This special episode is brought to you by FLIR, the world's sixth sense. I'm in Gloucester, Massachusetts, at the Ocean Alliance headquarters. Soon I'll be about 20 miles off the coast, floating in the Atlantic aboard RV Cachelot, a research vessel captained by Dr. Iain Kerr, the leader of Ocean Alliance. Ocean Alliance is a nonprofit dedicated to furthering our understanding of marine life and the vast ecosystem that it inhabits, which covers most of our planet. The organization have made a name for themselves by pioneering the use of drones in whale research. They first developed the Snotbot, a DJI Inspire 1 outfitted with petri dishes velcroed onto its fuselage. It flies, purposefully, straight into the cloud of snotty condensation that whales emit when they exhale. The snot sticks to the petri dishes attached to the drone and is later retrieved by the researchers for further biometric analysis. Today, however, our mission is a bit different. We're not going out looking for the whale snot, we're on an expedition to capture heat. Specifically, the world's first radiometric images of whales' blowholes from drones.
Just landed in Boston in the back of the Mitsubishi rental car. Mitsubishi Mirage, I want to say?
Outlander.
It's an Outlander. Mitsubishi Outlander Sport. We got the Outlander Sport. We're on the way to Gloucester, Massachusetts. And we are going to be looking at some whales with drones and FLIR thermal cameras. So, Randall, maybe you can give us a little bit, like, what is the objective? Why are we here? Why are we going to Gloucester? Why are we in this Mitsubishi Outlander Sport right now? And what are we going to be doing?
Sure. So a couple of years ago, I was introduced to Iain Kerr of Ocean Alliance, and they have been using drones for a while and studying whales. And anyone that's using this technology to do something interesting, obviously, as you're in the drone industry for a while, your ears perk up. And he's using thermal imaging cameras to get the first radiometric temperature reading of a whale's blowhole. That's what we're here for.
That was Randall Warnas, the global small drone segment leader at FLIR. Like me, he's not a scientist, but I'm here teaming up with him, FLIR, and Ocean Alliance to document this historic event. And okay, if you're like me, you may be wondering, why are we doing an expedition to peer down inside of a whale's nose using the latest drone and FLIR thermal technology to take its temperature? Well, for that, I'll turn it back over to Dr. Iain Kerr to explain.
Imagine you're in a classroom with 200 kids and you want to know what the kids are doing at the back of the classroom. You can't tell if you're standing at the front of the classroom. And that's what whale research has been like. We've been on a little boat on the surface looking at this log lying in the water. The angle's all wrong. So I actually think drones are going to have a much more profound effect on whale research than people realize. I actually believe in 2 or 3 years, if you're studying whales and you're not flying a drone, you won't be doing a complete experiment. Getting up in the air, looking down. I've worked with scientist Fred Sharp in Alaska studying humpback whales 25 years. He was just looking at the video feed and he was like, I never knew they did that. Of course that makes sense. Look how they're rolling over. Look how they're moving their pectoral fins. So we're getting a view into the world that we never expected. Now, if we're going to have more and more drones above whales, we might want to be looking for a new form of photo ID. And it seems to me that everybody, I'm just looking around the room, everybody at this table has a different shaped nose. And I'm sure if we learned the different shapes, we'd be able to identify that. So I'm just thinking that if we have more drones in the air looking down at those blowholes, it could be the shape of the blowhole, or it actually could be how the blowhole opens and how the animal exhales is a sort of identifying mark.
Pretty straightforward. Let's get an overview of the gear that we're going to be using.
So we have in front of us a Matrice 210. It's the FLIR package that was donated to us by FLIR. We've got the Zenmuse XT1 on it and the regular X4 camera. And we've actually received this beautiful piece of equipment and then actually spray painted it randomly with blue paint. So what looked like a piece of art now looks like a bad art project. But the idea here is that we're trying to make sure that the drone itself does not become part of the experiment. So we're trying to break up the sort of mechanical shape.
And so today we're going to be putting the XT2 on the FLIR Zenmuse XT2 on the M210 here. Is this the first time you've used the XT2?
That's correct. I mean, what's great about the M210 is you can carry 2 cameras, but then you're always calibrating 2 cameras. You've got to worry about having 2 cameras. With the XT2, we've got that both built into one, and actually there's some moisture resistance built into the XT2, and it's a foggy day today, so rather than be deeply concerned about a short, we've got the right gear.
So I don't know if you know that the XT2 has radiometric video. So you can just do. It's the first product we put out with radiometric video. So you can basically fly in video mode and then take a still from that video, and it still has the radiometric data.
Right. So we should try. But we should try both. We should make sure that we'll try both.
What kind of flight time do you get on this with all the sensors kind of tricked out on it?
Actually, we're still getting over 35 minutes. I think you have to remember, though, we're not aggressively flying. You sort of aggressively fly to the location, and then the drone pretty much sits at 10 meters, and we just slowly move above the animal, taking multiple photographs to try to get a robust data set.
Got that? Let me recap the situation and logistics. We're using FLIR thermal cameras, the XT2, and a DJI M210 drone on our expedition into the Atlantic to get the world's first radiometric thermal images of whales' blowholes. The reasons this mission is important are many, but to summarize, we'll help push scientific research forward by taking uninvasive biological assessments of some of the world's largest mammals. We'll take this new technology to its limits and discover how useful it is, and will gather critical data to help improve our shared global environment. Now, every meaningful expedition needs a good name, and since our mission is to capture thermal images of whales' blowholes with drones, we decided to dub this adventure Expedition Too Hot for Snot. We're about to depart, but before we do, let me tell you a bit about Iain's crew. First, we've got Britta Akerley, data manager, primarily keeping everyone on the same page while at sea, tracking whale identification and dive cadence. Chris Zadra, robotics program manager, responsible for the safe and efficient operation of drones. So what's going on here? You're setting up the takeoff pad?
Yep, this is our launch platform, so I'm just setting it up on the back of the boat so we can get the drone ready to take off.
Andy Rogan, science manager and marine mammal biologist. He's a wealth of knowledge and provides some pretty stellar facts and commentary about the whales.
These are its footprints. So when he's swimming underwater, right, then the upwelling from his tail is creating these big footprints in the water so you can see his trail.
And of course, Dr. Iain Kerr, CEO of Ocean Alliance and working with whales for over 30 years.
So we're all set aboard the RV Cachelot, that's research vessel Cachelot, and we are about to push off from the docks. The day is looking great. Really excited to hopefully go catch some whales with the Snot bot and the FLIR bot and get some internal blowhole temperature readings. Very cool stuff.
Yeah, well, about that weather. Turns out it wasn't so great. As soon as we left Gloucester Harbor, we were engulfed in a soupy thick fog that didn't allow visibility more than 100 feet in front of us. The mood became a bit somber. Our only hope then was to use our onboard navigation systems and plot a course for the area where we heard some whale watching tour boats were hanging out, and cross our fingers that they'd lead us to whales. So this is the unscientific part. It's really tough to find these things, especially in weather conditions with extremely limited visibility. Sometimes the best way to find whales in these conditions is to turn off the engines and just listen. I'm told that you can hear whales surfacing and breathing from many miles away. But where the whale watching boats were was an uneventful hour trek through the viscous curtain of mist hanging around us at that time. So rather than bore you with that part of the trip, let's turn our attention to a bit more background on Ocean Alliance, Dr. Kerr, and these amazing, magnificent creatures in which we were in search of.
It was a guy called Roger Payne in the 70s who discovered that whales sing songs. And I'm going to give you some whale recordings. I'm going to give you some whale recordings that are on the Voyager 1 and 2 spacecraft. And that's another whole story. They're in the heliosphere where the solar winds of other stars are greater than our stars. So I'm going to give you some whale recordings you can play. And I think in many ways Roger changed the way people thought about whales when he showed they were sort of singer poets.
Roger Payne founded Ocean Alliance.
When I was 30, so I guess around 30 years ago, I met Roger Payne on a beach in Argentina. And I was interested by the whole, the challenge of studying whales. If you're studying a giraffe on the Serengeti, it doesn't throw a bucket of salt water at you and disappear beneath the Serengeti and appear 5 miles later. It's actually difficult to study marine mammals. And even now, we don't study marine mammals at night. Yet acoustically, we tend to hear a lot more noise at night, which would suggest they're more active at night.
So we finally reached the whale watching boats, and all of a sudden, just as it happens in the movies, humpback whales appeared, seemingly out of nowhere. We were surrounded.
Look at this, everywhere you look.
What is this?
Oh, everywhere! This is amazing. Just one by one, spouts, humps, surfacing. They're just chilling. So we're getting some drones up. There's a tail. Yeah.
Another tail.
What are the chances that one of these are Cajun, the one that I adopted?
No, could be, absolutely. It really could be. The way our luck is going. I mean, let's be clear, we had total fog. We arrive at the whales and we're now in this island of visibility with fog all around us.
Instead of being enveloped in fog, we were now encircled by at least 6 of these massive mammals. So it was time to break out the FLIR bot, or hot bot, as Dr. Kerr was fond of referring to it as.
I just at 1 o'clock, about 200 meters. Okay, this. See him?
Okay, so the drone is now in the air with the FLIR sensor attached to it. Dr. Kerr and Chris are taking turns flying 35 feet above the whales as they motor along, none the wiser that there's an incredibly advanced piece of bleeding-edge robotic tech hovering above them. And it's going really well. Every time the whales surface, the drone gets into position. The whale finally exhales, then takes a huge breath, opening its blowholes wide and filling its lungs with hundreds upon hundreds of gallons worth of sweet, sweet oxygen. And that's when the finger clicks the camera button on the remote. That FLIR camera is capturing the world's first thermal radiometric images inside of whales' blowholes. A metaphorical collision of thoughtful science, raw nature, and high technology has just occurred. But let's dive deeper into the science behind these FLIR cameras. Here's Randall to explain how they work.
So there's a lot of variables within getting a good radiometric reading from a thermal imaging camera. Basically, you're taking the radiation that comes off of everything, either as emitted, reflected, or absorbed by every object around you. And these cameras then take in these variables and calculate it into a temperature reading. So we're taking radiometric images, so we're going to take a proprietary file type, which is a RJPEG, radiometric JPEG, and that retains all the temperature data within each pixel of the image so that we can then manipulate the variables to get the best outcome. We can post-process it. If we just took a JPEG, it's just gonna be colorized image, and we can maybe manipulate the colors, but that's really not that interesting for science.
FLIR sensors may sound complicated, but in reality, they're simple to use. They just work, and they look incredible. Being able to see and measure heat so clearly almost makes you feel like you have superpowers. After all, FLIR's slogan is the world's sixth sense. And listen to this. This is Randall looking at the FLIR images as they're being taken on the boat. He is absolutely beside himself.
No way! Joseph. Amazing.
Oh, you can see the the blowholes.
Coast Guard Station Merrimack River, this is Coast Guard 29184.
No way. This is the drone screen, but you could see the whales like...
There you go, 3, 2, yeah, 1, yeah.
Perfect.
You got it.
No way.
And this guy works for FLIR. Somehow this feeling of excitement hasn't gotten old for him yet. And I can pretty much see why. The whales were displaying normal and active feeding behavior, but gradually became totally docile once the big whale-watching boats left for shore to pick up another group. What we experienced then was, apparently, incredibly rare.
Yeah, this animal's going to come close to us here. Hear that sound?
Oh my god. There's a whale 30 feet from us. Drone is right above it with the thermal camera. Getting insane. I hope you can hear it when it comes up to breathe. Insane footage and data.
There we were, all alone in a humpback paradise, floating within 15 meters of 3 100-foot-plus giants. The whales weren't moving, and I never imagined they could be so still. It really seemed like they were almost taking a nap. They were so lackadaisically comfortable with us that they must have really just dozed off. Occasionally, the silence would break with a hulking, stinking exhalation of whale breath that so gracefully floated with the breeze to coat all of us with a thin layer of snot. We had become the snotbots, and I relished every moment of it. After only a handful of hours in the Atlantic at Stellwagen Bank, we'd gotten what we came for. Our SD cards were full of audio and imagery, and it was time to head back to Ocean Alliance headquarters in Gloucester. The ride back was uneventful. We docked, disembarked, and Randall and I bid our farewells to the Cachelot. We wouldn't be gracing her deck again anytime soon. The next morning we woke up bright and late to a ton of rain. Unfortunately, everything worked out perfectly because 2 days in Gloucester was all we'd budgeted anyways. And now the moment of truth. Time to sit down and take a look at the imagery.
Iain, can you tell me kind of what are we looking at here?
Well, this screen is amazing, and this screen came courtesy of FLIR tools. On the right-hand screen, we have just the regular image, JPEG image of the whale. So we can see the whale, the ocean, the water, the blowholes. And on the left-hand screen, we actually have the calibrated images of the blowhole, where it's giving us the maximum temperature, the minimum temperature, and then a mean temperature. So we can really look at these two images and have an understanding what's going on. And it's very exciting. When you look at all the options we've got here, it actually looks like we can see sort of the interior walls of the blowhole because they're colder. So there's a lot of interpretation of this data that we still have to do. But in these early days, clearly we're getting the type of data we want. And already it's getting us to ask more questions. That's what you want in science. You want to be posing more questions. And what's interesting is this group of whales we were working with yesterday were really just lying around. It looked like they were resting. They were doing 30 minutes on occasion surface intervals, where they're just lying there for 30 minutes. The previous data set we've got, the animals were very active. They were diving 4 or 5 minutes at the surface max, and then down from 12 to 15 minutes, 3 or 4 or 5 minutes at the surface and down. And guess what? Their body temperatures were higher. So it sort of makes sense. You know, if you're out jogging and you come home, your temperature is going to be higher than if you were resting. And if I could throw one other component, I've shown you a couple of these photographs. We're also seeing other markings on the body of the whale. And I don't know if these are parasites, if it's slough skin, but is this some other information data set that we'll be able to use? It's funny because I know FLIR likes to say we're the world's sixth sense. But no doubt about it, we're looking at these animals with different eyes, and guess what? We're getting images that we weren't expecting.
Expedition Too Hot for Snot was a success. Admittedly, these days it takes quite a bit to impress me with drone technology. After many years in the industry, I've become a bit jaded. But experiencing these FLIR images being taken firsthand and scrutinizing the final results has left me with goosebumps on more than one occasion. Before I left, I asked Dr. Kerr, how can someone who's listening to this podcast help or contribute? His reply? Do what you're good at. If you're great at painting, create art that can help make a difference. If you're into technology, you can recommend any gear to Iain that Ocean Alliance could use in their research and expeditions. And if you want to make it a career, you can study marine biology. And of course, you can also go to whale.org and spend $5 to adopt a whale. It can make a great gift, and I'm proud to say that myself and the podcast have adopted the whale named Cajun. I've never met her in person, but I'm sure she's doing great under the watchful eye of Ocean Alliance. It's a special thing we've got, our pale blue dot, and the ocean is such a critical part.
Let's be, again, a little proactive. If you're driving the car and the front wheel feels like it's wobbling, you stop the car, you have a look, you tighten up the wheel, you don't speed up. I think it's time for us to understand, again, we live on planet ocean, and it's in our own self-interest to have healthy oceans, and whales are key to helping us know what's going on.
Be sure to go to commercialdrones.fm in your web browser to check out the accompanying FLIR thermal imagery of the blowholes themselves and some jaw-dropping drone pictures of other whales that Iain and his mates have captured. Again, that website is commercialdrones.fm. It was so fun making this episode, and there are a few folks to thank. I want to say thank you to Randall Warnas and FLIR for making this possible. Jocelyn, it was great meeting you. Thank you to Dr. Iain Kerr, Britta, Chris, Andy, and the rest of the Ocean Alliance crew for being such generous hosts, for having me aboard your ship, and for teaching me so many new things. Keep doing what you're doing. And thank you for listening. If you liked what you heard, subscribe to the podcast on Apple Podcasts, Spotify, or anywhere else you listen. And be sure to check out past episodes of Commercial Drones FM. It's free. Stay tuned, and I'll be coming back soon with the next one. All right, I'm cutting off the mic. Cheers.
What happens if we don't see any whales today?
I'll jump overboard.
Deal. Then we'll get the radiometric temperature reading of you.
Try to
There we
find
go.
me. Yeah,
That's right.
I'll swim on my back.
Of your blow.